Welcome, my friends. In this video, we will discuss the Pythagorean Theorem. You may have heard the phrase, the shortest distance between any 2 points is a straight line. Generally, this is true, not just with coordinate points in math, but also in the real world. The shortest distance between any 2 cities is generally going to be a straight path from the first city to the second, assuming a straight path exists. Consider these 2 points, A and B. Let's say that the horizontal distance between the 2 points is 3 units. Maybe 3 miles or 3 meters or whatever. I'll just leave it as 3. The vertical distance between the 2 points is 4. One path to get from point A to point B would be to first travel the horizontal distance, 3 units, and then travel the vertical distance, 4 units, for a total of 7 units. But of course, that would be an inefficient path, assuming that a straight path between A and B exists. The shortest distance between any 2 points is a line, and assuming that we can travel from A to B in a straight line, that distance should be less than 7 units. Our goal is to find the unknown distance d here. It turns out that the square of the distance can be found by first squaring and adding the 2 distances traveled on the inefficient route. D squared is equal to 3 squared plus 4 squared, which gives us 9 plus 16, which is 25. Then we can take the positive square root of our result, which gives us the square root of 25, which is just 5. This tells us that the shortest distance from point A to point B is 5 units, a whole 2 units less than when we traveled the inefficient way. If these distances represented miles, traveling in a straight distance from A to B would save you 2 entire miles. Wow! The Pythagorean theorem is a generalization of this process and applies specifically to right triangles. Let me label the triangle a little bit differently in general form. We have 2 legs with lengths lowercase a and lowercase b, and then we have the shortest distance between our 2 original points, which is lowercase c. In general, we call A and B the legs of the triangle. We call C the hypotenuse of the triangle, which is always the side opposite to the right angle, and is also always the longest side. The way you can identify the hypotenuse is by first finding the right angle, which should be indicated by a little square on one of the angles of the triangle. Once you have identified the right angle, the hypotenuse is the side directly opposite, which is generally labeled as C. In practice, it doesn't matter if sides A and B are switched around, but it's very important that you correctly identify the hypotenuse as side C. Otherwise, you will not get the right answer. The Pythagorean theorem applies to right triangles and states that if you square each of the legs of the triangle, A and B, and then add them together, you will get the square of the hypotenuse. In other words, A squared plus B squared is equal to C squared. If you want to find the hypotenuse, all you would need to do is to take the positive square root of both sides. Here is a triangle that is oriented a bit differently. We have a missing side x that we want to solve for. The first thing to do is to figure out if x is the hypotenuse, or if x is one of the legs of the triangle. We see here that the right angle is between the 2 known sides. Remember that the hypotenuse, which we label as C in the Pythagorean theorem, is always opposite to the right angle. That means x must be the hypotenuse, as it is opposite to the right angle. Therefore, 7 and 6 are our 2 legs. So we have A is equal to 7, B is equal to 6, and C is equal to x. Again, it doesn't really matter if you mix around A and B. All that matters is that you correctly identify the hypotenuse. Applying the Pythagorean theorem, we have 7 squared plus 6 squared is equal to x squared. This simplifies to 49 plus 36 is equal to x squared. This simplifies to 85 is equal to x squared. If we take the positive square root of both sides, since the negative square root really wouldn't make a lot of sense for a distance, we get that x is equal to the square root of 85. If we want a decimal approximation, then we can type this into our calculator, and we will get approximately 9.22. The hypotenuse is approximately 9.22 units long in this example. You should always check to make sure that in your final answer, the hypotenuse is larger than the other 2 sides. It looks like that is the case here, as 9.22 is indeed larger than both 7 and 6. Let's try one more problem. Say that we have this triangle, and again we would like to solve for x. Just like before, we should figure out if x is one of the legs or if x is the hypotenuse. If we look for the right angle, we notice that the opposite side is already known. It has a length of 11 units. That means that our hypotenuse, c, is equal to 11. A equals 10 is one of the legs, and the other leg is our unknown side, which is just x. Plugging into the Pythagorean theorem, we have 10 squared plus x squared is equal to 11 squared. This simplifies to 100 plus x squared is equal to 121. If we subtract 100 from both sides, we get x squared is equal to 21. Taking the positive square root of both sides, we get x is equal to the square root of 21. Many times this might be an acceptable final answer, but if we want a decimal approximation, we can type the square root of 21 into our calculator, and we will get about 4.58. If we check back at our picture, we can verify that our hypotenuse of 11 is indeed our longest side. Note that this picture is not drawn to scale. Alright my friends, that finishes up my video relating to the Pythagorean theorem.